Hello everyone, thanks for tuning in. Today we're going to talk about functions and modules in Mathematica. So if you want to find out the syntax for these commands, let's say function, you can type question mark and then function and then shift enter, and Mathematica will give you information on this command. You can also type click here on local, and this will take you to the local documentation, or click here and you'll see the web documentation. So let's consider a first example. You can always, of course, define a function like this. F of x equals 3 plus x, let's say. And then if I ask for f of 5, I'm gonna get 8, or if I ask for f of y, I'm going to get 3 plus y, and so on. Let's just look at a few other ways to define a function. So you can use the syntax u and then 3 plus u. So the first argument is the variable and the second argument is the function. And then let's specify that I want actually this to be a function of x. You can do it like this. Specify here the argument of your eventual function. And that is going to give you the function 3 plus x. You can also do the same thing without using the variable u, by using a generic character in its place, which is the sharp character. And then you can again specify the argument by putting x in brackets. So this is again the function 3 plus x. You can also use a pure function. So I can type 3 plus sharp and then ampersand, and then specify that this is a function of x. And again, this will apply this pure function onto the argument x and map it onto 3 plus x. I can, let's suppose I want to give a name to this function. Then I could type f equals three plus sharp and then ampersand. And this has defined f to be a pure function. If I apply this function onto some variable, let's say t, then I get 3 plus t. So this pure function gets applied onto the argument t. If I type f plus 5, I get 8, and so on. Okay, so this is a way, these are some of the ways of defining a function of one variable. Now, let's suppose that I want to define a function of 2 arguments. Let's suppose I want to define the norm. Let's call it my norm of x and y. And that's the norm in Euclidean space. So that's x square root of x squared plus y squared. This is one way to do it. So now if I apply this function my norm to x equals 3 and y equals 4, then I'm going to get the result that the hypotenuse is 5. You can also follow the earlier syntax, this kind of syntax, using the function command. So I could say my norm equals function, and then specify the arguments u, v, and then I'm just gonna copy paste it from here, square root for u and v, u squared plus v squared. And then you actually want to specify that this is a function of x and y. So these are the arguments of my function, my norm, that I'm going to use in the end. So let's use this definition. Again, you get square root of x squared plus, I have a typo here, this should have been by norm. But anyway, so let's type my norm of 3 and 4, and we get 5. Okay. So we can also follow this syntax that we showed here of defining a pure function without using a variable name in the definition of the function. So I can say my norm, and then x and y equals square root, and then you can name your variables using #1 squared plus #2 squared, and then ampersand. So this defines a pure function where the first variable gets squared and then the second variable gets squared. And then we apply this, we map this onto x and y. So these are our arguments now. And again, this gives you a definition of the function square root of x squared plus y squared. And if I apply this to the numbers 3 and 4, I'm gonna get the right result, 5. I could also do this without specifying that x and y are the arguments. So I could completely omit this. So I can just define a pure function like this without the arguments x and y. And now this is a pure function, just like I defined a pure function here, the pure function f. Now I define a pure function, my norm, that looks like this. And then I can apply it on any two variables. So let's say 4 and 5, and I get the correct result, or 3 and 4 like before, and so on. Or I can type a and b in here, and this function will get applied onto the arguments a and b. Okay, so this was a way of defining a function of two variables. You could also consider the variables, the arguments of the function to be vectors. So, for example, let's define the same quantity, but let's call it vector norm, and let's specify the argument to be a vector, capital X, and the norm will be the same as before, square root of the first component of the vector plus the second component of the vector. If you're not familiar with vector notation, you can go back and watch the previous video where we talked about lists and vectors and arrays in Mathematica. Okay, so this defines a vector norm, and the argument here is going to be a vector. So in other words, it's going to be a list. So let's pass a list 3 and 4 into this function, and we get 5. Now, you can make this function a little better, because if I want to apply this in 3 dimensions, for example, the third dimension gets ignored because I haven't included that in the norm. So to fix that and to make this evaluation faster, we can simply, instead of taking each component of the vector x and squaring it, we can just compute the dot product of the vector x onto itself. And again, you can look at the previous video on vector multiplication, where we use the dot product between vectors to multiply vectors. So x dot x is basically the inner product between the vector and itself, and then we can take the square root of that. So if we ask for my vector norm of the vector 3, 4, we get this result. And if there is another component, then we get a different result. And I can pass, of course, x, y, z coordinates, and then I'm going to get the vector norm in 3D. Or I can add a fourth component, and I'm going to get the vector norm in 4D, and so on. So this definition is a bit better than this, is because it's more general. Okay, so after discussing functions, let's discuss modules. So modules are used in Mathematica to do a few more operations and define them as functions. So to find out more, you can type question mark and then module and shift enter, and you can look at the local documentation for the syntax. So let's suppose I want to define a module that's called my power or my pow. And let's suppose that this accepts a variable x and returns a result x to the 1 over x. So let me type this here in a comment. We will define a module my power that accepts a variable x and returns a single result x to the power 1 over x. Okay, so the first thing I need to define is the argument. So let's suppose the argument is x0. And then I can use a delayed equals to define the module, so that the module gets evaluated only when I call it. And then in the module, I can specify some arguments and pass them on to the module. So I can type x0 here. So when I call the module, I will call it with an argument that will have the name x0, and then the module will set that x0 and use it as input and set it equal to another variable x that will be used inside the module. So the input quantities of the module are registered first here inside curly brackets, and then you have a comma, and then you can type some commands that you want your module to do. In this case, we want to take this variable x and raise it to the power 1 over x. One way to do this would be to define another variable that will be a local variable that will only be recognized inside the module, and let's call that variable a, which is the power 1 over x. And then we can do more operations. In this case, we want to, for example, to define another variable, and that will be the output variable, which will be x to the power a, or x to the 1 over x. So in this case, y is the returned variable because it comes last in the module. So always the last quantity inside the module is the quantity that is being returned by the module. So if I do this and then I apply this function to, say, the number 4, I get square root of 2, or let's do 5, and I get 5 to the 1/5. So this is x to the 1 over x. Of course, this would be the same thing as defining the function f of x equals x to the 1 over x. So this would have done the same thing, of course. The problem now is I got a wrong result because there's a conflict with my earlier definition of f. So I need to clear f by saying f equals dot. And then if I type f of 5, it's not cleared yet. Let's try clear f. And now change color. Now it is cleared. If I type f of 5, I get f of 5. So the previous definition of f is not being used. So now I can define this function f. And if I ask for f of 5, I get 5 to the 1/5. Now, modules, sometimes they're listable, sometimes they're not. You can try and apply this module to a vector or a list of values, and our desire is to get a list of results. The module, we want it to be applied to each and every element of this list, and indeed this is what happens. If this does not happen and you get an error, you can use the command set attributes and then listable. So to find out more, you can say question mark and then listable, and then you can read about the documentation of how to make a quantity listable. So we can do that when we need to. Okay, so far we have seen examples of functions or modules that take one or more arguments and return one number, one scalar number as a result. So let's look at another example where we take a vector as a result, as the argument, and then return a result. So let's suppose I want to calculate the average of some numbers in a list. So I can create a function or a module, call it my average. Let's suppose that we name the argument x0 and use delayed equals and then module as before, and then we pass this input x0, this argument as input to the module, and call it x. And then to calculate the average, we need to divide by the number of elements. So the number of elements is given by the length command. So let's calculate the length of x and call it n. And then we want to calculate the sum of all the elements in a vector. To calculate the sum, we can use the command total. Of x and call that quantity s. And then we want the module to return the sum of all elements divided by the total number of elements. So that's s divided by n. Okay, so let's test this. Let's create a vector. You can use the range command from 1 to 99, and that gives us a list of numbers, and then we can ask for the average of the numbers in this list, and the average of course is 50. You can also use the Mathematica command mean to calculate the mean, and that will compute the same thing. If we wanted, we could define this function a bit differently. So for example, instead of passing x0 as input here, and then defining these quantities n and s, I could simply calculate the total of x here and the length of x here, and not compute these intermediate quantities. That is obviously a bit simpler, but that does the same thing. So if I ask for my average of z, I get the same result. It's also possible to do some of these assignments, n equals length of x and s equals total of x. This could be done in here. So for example, I can type my average, and then instead of setting x equal to x0, I can just directly say n equals length of x and s equals total of x, and then I don't need these definitions anymore. I'm simply initializing the input arguments of the module. So I'm simply passing a quantity x to it, and I'm setting length of x equal to n and total of x equal to s. And I'm not using x any other way, so I don't need to set x equals x0 or something like that. So I can simply divide s by n, and I can apply this to any list, and that's going to give me the same result. So these are three equivalent ways to define the average of a list using a module. And of course, you can try it on something simpler. And that's going to give you the right result. Sometimes you want to return not a number, but many numbers. So you can return a vector of values or a matrix of values and so on. So the way to define a vector valued function would be to use a list. So we talked about lists and vectors in the previous video. So let me write this here. A function with 2 input arguments and 2 output values. So as an example, let's suppose we're giving a vector in Cartesian coordinates, and we want to return this vector in polar coordinates. So our argument will be a vector x in Cartesian coordinates, and then we want to return a vector with 2 components, the radial and the angular components. So the radial component would be the square root, and then we can use x of 1 squared. That's the x component of x, and then the y component of the vector, and take the square root. So that's the first component of the vector. That's the radius of the vector, or the modulus of the vector. And then the second argument will be the angle or the arc tangent. So that's the arctangent of y over x, or x2 over x1. And then we close the curly brackets. Okay, so that's our formula for polar coordinates. And now let's try and pass a vector into it. So let's try 4, 3, and these are the radial and angular coordinates for this Cartesian vector 4, 3. If I wanted to do the same thing using a pure function, I could define a pure function polar, and then avoid introducing x1 and x2, and instead use sharp 1 and then sharp 2, and again arctangent of sharp 2 divided by sharp 1. And then I need the ampersand to define a pure function. Now the issue here is that you have to apply each element of this list onto an argument when you want to evaluate this function. So to do that, I can use the character at and then apply it to this vector. So this will apply each of those pure functions to each of those elements of this. No, actually not to each of those, but to the whole list as input. And now we get the correct result. Okay, so this wraps it up for this video. Thank you for watching.